Hey guys, welcome. Yeah, so our third example on the Weirstrass substitution. But yeah, in this problem, before we use the Weirstrass substitution, let's first do this nice little trick, which is write the numerator as sine x plus 1. To make up for this one we added in the numerator, we go minus 1 and all over this denominator, right? But yeah, instead of writing it over the whole thing, I'm gonna split this into two rational expressions. So sine x plus 1 over 1 plus sine x, which is the same as sine x plus 1 here. And then in this part, I'll write it as 1 plus sine x and then dx, yeah? Okay, cool. And now notice that this is just 1. And so we can split this into two integrals, where the first integral is the integral of 1 dx, or simply the integral of dx. And the second integral is, so minus, that's the minus sign, so integral of 1 over 1 plus sine x dx, like that, right? And it is here where we're going to need the Weirstrass substitution. Now, in example 0 of the Weirstrass substitution, we started with how all Weirstrass substitutions must start, which is by letting u or t or some other letter equal tan of x over 2. And so by starting this way, and again, all Weirstrass substitutions must start in this way, but yeah, by starting there, we saw that dx is going to equal 2 du over 1 plus u squared, and sine x is going to equal 2u over 1 plus u squared. So if you want to know how to get this and this by starting with this, watch example 0 on the Weirstrass substitution. Okay, all right. But yeah, with these guys handy, we can now tackle this second integral. In particular, it becomes this, right? It becomes the integral of 1 over 1 plus 2u over 1 plus u squared. So this here is 1 plus sine x, and then times dx, and dx is this. So I'll write the 2 du part of dx right here, and then the rest of it will have to be 1 over, and let me put this in parentheses, right, 1 plus u squared here. Now, I think the easiest algebra we can do moving forward is to distribute this here to these two guys. So multiply 1 plus u squared to 1, and then plus multiply 1 plus u squared to this quotient. Yeah? Okay, so we need the space. And if we do exactly what I just said, what we're going to do, what we're going to get is 2 du over, and then this times 1 is just 1 plus u squared, or u squared plus 1. And then this times this quotient is just going to be plus 2u, right? And so there that is. And yeah, now this here we could write as u squared plus 2u plus 1. So u squared plus 2u plus 1, right? Okay, and so then this is going to equal 2, and I could write the 2 in front here, 1 over, and then notice that this is from algebra u plus 1 whole squared, right? Okay, and of course then next we could go, oh, what we have is the same as, well, first this is u plus 1 to the power negative 2. So we get u plus 1 to the power negative 1 over negative 1. But no need to write over negative 1. I could just put the negative in front of the 2. And this is really 1 over u plus 1, right? And so this is cumbersome too. I could just write a negative 2 right here, right? Okay, and that's what we've got. So first, the integral of dx is just x, right? And then next, we just found out that this integral here that I just erased is the same as negative 2 over u plus 1, right? Okay. But then we see that this is the same as plus, right? But u, I erased it, is tan of x over 2. So tan of x over 2 plus 1, and dn plus c, and done.